One, two, three. Good afternoon, everybody. I guess you can hear me. Thank you very much. Thank you. I'm very happy to be here today. It's a pleasure. I sincerely hope that you have, as we have, a lot of pleasure to be at this new WNE session. I think it's a great new session after 2 years, and definitively it shows how nuclear is becoming a big topic of interest for everybody. So I am Frédéric Chénaud. I am a Business Development Director for Assystem, especially in charge of international market. And so I propose to open the discussions today and to talk about qualifying, identifying some potential sites that will welcome SMR, the famous new SMR that shall be a revolution in the nuclear world. To make it efficient, because I'm not a technical expert as my colleagues are, I have proposed to invite my two colleagues, Onur and Gizem. And please, if you can introduce yourself to the audience, it would be nice.
Okay. Thank you. This is Gizem Özden. I'm shouting, right? Okay. I'm the Business Development Director for Environmental and Siting Services with a specific focus on nuclear site characterization. I've been in the industry for around 15 years, and 5 years is just dedicated to nuclear site characterization. Thank you.
Good afternoon. My name is Onur Öztuncer. I am the Operations Director for Assystem Turkey, and I've been in the energy industry and the project finance sector for more than 15 years. Welcome again.
So let's jump on the topic now of this discussion. I'm sure I don't really need to explain to you what SMR are, but if we want to make it short, SMR are industrial plants that shall produce less than 300 megawatts, according to some official definitions. And of course, the promises of SMR is that it shall be smaller, and the construction time shall be quicker. And again, in terms of construction, the modularity shall bring some very, very big advantage to develop SMR in many geographies. But in fact, there is one question that I would like to ask to Gizem. What is the difference between SMR and EMR? I don't know if you are expert, but in fact, it's not so clear for me. Gizem.
Okay. SMRs are generally based on Generation 3 plus pressurized water reactor technologies, which is like closer to commercial readiness. Whereas the term AMR, which is the advanced nuclear reactors, they are based on Generation 4 technologies, I mean, generally. And it will take some time to get ready for this kind of technologies.
Thank you, Gizem. We have to admit that whatever we say about the beauty and the promises of SMR, most of the SMR today on the market are still at the design stage. They need to work in terms of engineering, in terms of regulatory process. And again, something that is very promising for everybody is that it can be used for different purposes. Electricity generation, even producing water in terms of desalinization process, and heat. Definitively, it is something of interest for the industry. And it means also, to come back to the purpose of the speech today, that in terms of siting studies, there are many things to be prepared, to be anticipated. And this is what we propose to develop today with you during this quick speech. As a system, we have a very large proposal to the market, depending on what a customer wants. And to make it very short, we can support the companies that are developing new SMR technology. And after that, or in parallel, we can also support the countries or the industries that want in the future to select some SMR for their own use as industrial application. Depending, of course, on the position, and depending, the service lines will be different. Onur, can you please tell us a little bit more about what we will explain to the audience in the coming minutes?
Sure. Actually, as part of the site characterization studies, we perform a lot of different studies on the site and in the off-site, in the back office. On the off-site, we can do geotechnical studies, geophysical studies, bathymetry, volcanology, meteorology, ecology studies, flood assessments. And in the offshore, actually, we also do some geotechnical and geophysical studies. But today, we are going to focus on really the site selection and how site characterization and site selection come together, actually. And we would like to present our solution combining these two different parameters at the pre-selection stage.
Thank you, Onur. As a last conclusion slide of my introduction, I just want to recall that Assystem, we are already very involved in this new SMR industry. You can see some of the name of the customer that we are supporting. We are definitely very proud to support these companies. It shows, again, the interest of this industry and the benefits that engineering firms like Assystem can propose. And we expect in the coming months and years that some new customers, new developers will come on the market. And of course, for us, it will be a very big topic of satisfaction to continue to develop this new SMR industry. Onur, Gizem, the floor is yours. And you have your remote.
Okay. So as we spoke about advantages of SMRs and AMRs that will bring in the nuclear installations, which is like low cost, easier to install, factory production, and it becomes with the, of course, smaller size. So the footprint of the SMRs will be less than the large nuclear power plants. So when you compare the SMRs to the classical large nuclear power plants, SMRs, AMRs, notably high temperature gas reactors, molten salt reactors, such as lead fast reactors, they feature by design smaller cores, with increased use of passive safety systems, and this will allow the core to shut down automatically while remain cooled without external power. So these advantages will bring some advantages onto siting as well, because as you may know, the siting process of large nuclear power plants takes minimum 2 and 2.5 years. So, okay. So as you may already know, the siting process of any kind of nuclear installation is governed by IAEA SSG 35 guideline. And when you do the siting process, you start with site surveys, which is in the first item here. And in site surveys, you identify potential sites, potential regions, and then sites, and some candidate sites. And you do some screening. And you do some ranking, you do some comparison among the sites, basically. And then you, after site surveys, you will have some determined, or you determine some selected alternative sites. And then you do some comparison among these selected sites, and you do some rankings based on some evaluation criteria, which Onur mentioned, like geology, seismicity, like hydrology, environmental impacts, etc. So there are tons of lists that needs to be covered. And after this, you make some ranking and you decide your preferred site. You select the site, basically. So, and since SMRs, as I mentioned, will have smaller footprints, the potential sites for SMRs will be higher than the number of potential sites for large nuclear power plants. This is why we need to have some agile tool for it. So we have, okay, the problem is we need to choose the ideal site for SMR, which like maybe for large nuclear power plants, you will have 60 potential sites, but for SMRs, maybe you will have like 1,000 of potential sites. So you need to overcome this problem by involving like a large number of parameters. So that's why we have a simplified approach, a more agile approach and tool to select your ideal site or the preferred site, let's say, for your small or advanced modular reactors by using the data on hand plus the help of artificial intelligence and our modeling capabilities. No.
Perfect. Okay. Among these all parameters, we actually try to focus on 7 main parameters. One of them is the transportation, the other is topography, the water source, population, geohazards, which could be seismic fault lines or landslides, the environmental data, and the restricted areas. So we believe that based on these 7 major categories, and if we can able to prioritize these or give some ranking to these, we will be able to reach or access to the most optimized solutions and the sites on the field. While considering these, we believe that Assystem solution is going to add 2 game changers to the industry. One of them is the grid impact study, the other is the climate considerations. For the grid impact study, we have already completed full grid impact study for the Uzbekistan, for instance, and some part of Saudi Arabia. And for the climate considerations, we have built in-house modeling capabilities for the next 15 years, actually, which we are planning to implement after we selecting the parameters and selecting the alternative sites. Okay, and we focused on 3 key questions. The first question is which location we would like to focus on, or which alternatives we would like to focus on. The second question is what is our grid impact, actually, because as you know, SMRs could also work on some weak grids comparatively, but in any case, we would like to actually simulate the real impact to the grid itself. And we would like to focus on the optimization and the ranking between different sites. And our offer actually is a multi-criteria decision analysis model, which is a very well prepared, which incorporates nuclear safety considerations, adjustable, and in the end is going to be a very cost-effective solution even at the beginning of the process. Okay, our aim is to create a simple solution, very complex problem, for a complex problem. As Gizem mentioned, there are a lot of different opportunities and a lot of different parameters, but we would like to simplify this process by going step by step, actually. Our first step is the GIS pre-processing. When we select the area or the region, we would like to apply all GIS pre-processing data. And following that...
Can you maybe just recall what means GIS for those who don't know?
Sure. It's Geographical Information Systems. So any type of geographical data, map, or any type of constraints based on the water bodies or elevation, we can incorporate it into here, and it's going to be pre-processed. And step 2 is really selecting the region or the country altogether, and you are going to define your interests and your constraints. And then we are going to select and rank between alternatives. We are going to insert the climate and grid simulation information on top of it, and you are going to get the result in the end. While performing all these 5 steps, actually we are using a lot of different open source software. We are using DigSilent for the grid impact study, Python, OpenStreetMaps, ArcGIS, Copernicus data, and PostGIS softwares, actually. Before going to details of the tool, I would like to show you the WebGIS application. WebGIS application is already developed in-house by Assystem, and it's been used for the last 5 years in different regions of the world, actually. And as we mentioned before, the site characterization studies allows geoscience, environmental, and social studies. And within the WebGIS application, we would be able to visualize and embed all the related information, whether it could be the data gathered from the site or literature data. It's embedded in the WebGIS application, and all the data is converted to geospatial data forms, which can be easily digitalized for better traceability. This is one of the projects that we worked last year, actually. It's around 165, 170 kilometers. And within this route, actually, we did more than 250,000 geophysical tests, and we gathered more than 271,000 coordinates. All of the data sources are already implemented in the WebGIS, and we can visualize, we can reach the data anytime you want. It could be from the contractor side, it could be from the investor side, it could be from the owner, actually. Everybody who has access anywhere in the world from the web pages can access this data and verify the process. Now, we are going to put this module inside the WebGIS site selection solution. And I would like to go over how it works step by step. So this is the first step of step 2, actually. And in the first step, we are going to select a territory or a part of the territory. Here, for instance, we are selecting the SMR technology, we are selecting Morocco, and we are selecting some specific region, for instance. Or you can select the whole country. And after you select this, behind the scenes, actually, we are going to rely on a wide range of data sources. It could be publicly available data, it could be purchase data, or it could be some real data that you gathered on site and you embed into WebGIS, which could be used as an exclusionary criteria or a discretionary criteria in the later phases. So our data pre-processing, after you select the region, going to combine the open source and the client data all together. Now the fun part starts actually. After the pre-processing, you have the power actually to select the constraints, and you can assign some ranking and some capacity factors, some different parameters or constraints to that. For instance, we are showing you the capacity, so it could be from 50 megawatts to maybe 4,800 megawatts. Based on this scalability, actually, our tool is going to run behind the scenes so that we are going to do some mesh and some grid impact, grid analysis after that. By selecting these, actually, if your priorities shift, or if you would like to, if you have a change of mind later in the process, you can go back, try to start from the beginning, and select the parameters, the constraints, and define some limits to them. The step 3 actually is composed of the ranking. After we establish the sites, alternative sites, we would like to rank them. So our approach is using grid studies, gridding actually. We are going to make up a mesh, and for instance, for our Morocco example, we have 4.5 million grids, each 0.12 kilometers square, which you can fit 350 to 450 megawatts of SMR. So based on these gridding studies, we can assign different levels of suitability for each site, and we can able to rank it, and I'm going to show it how we are going to do it in a tool within next couple of slides. This is one of the things that I mentioned in the beginning as a game changer, the grid connectivity and optimization. We know that after you select a site, actually, the grid impact is really important because it's going to affect, you would like to minimize your disruptions to the already very saturated grid maybe. And then by using our tool, we would like to consider some factors like capacity, connectivity, and resilience. And by taking these considerations, we are going to see some violating substations maybe, and you can see some adjustments how you can deal with it. The next one is regarding the climate change adaptation actually. So we know that our solution, we know that climate change is a real issue actually in front of us, especially for the SMRs also. And we are using an in-house developed model, a prediction model for 2024, 29, 34, and 39 for the next 15 years. And we are working on the 4 distinct parameters here again, mean sea level, sea water temperature, ambient air temperature, and the drought prediction, which is an indication of more than 40 degrees, the number of days in a month, which is more than 40 degrees. So you select the area, and maybe you are curious that in 15 years, is there a risk actually? In 20 years, is there a risk of this area going from wetland to dryland, or if the sea temperature is going to raise some amount? So here we would like to implement this as part of our solution. And finally, part of our solution again is regarding the OCR capabilities. Here, by using artificial intelligence and also by using in-house modeling effects, here for Morocco, for instance, we have lots of data in Arabic, which is one of the hardest language actually. Our OCR tool actually can convert the tables, the coordinates, and the text itself to some meaningful data for your site selection in the OCR part. So you can see some restricted areas, or some restricted zones. You can convert them to KMZ files or shape files. Also, you can get some coordinates based on the text that you already have. Okay, we would like to go over the tool itself. It's a 2-minute video, and I would like to also talk while we are going there. So hopefully this is going to work. So in the tool, you select SMR technology, and you select the Morocco, for instance, and then you select the Tangier region. It's already visualized. And in the capacity, you would like to select, I don't know, 450 megawatts, 500 megawatts. And then you can see the settlements actually. And you can set the limitations of these settlements, whether you would like to be close or away from the settlements. And then you will have the water bodies, not only seas or ocean, but also all of them. The substations, seaports, roads actually, the railways. And then you will have some forest area, protected area, and some restricted zones. So everything could be visualized here. And after you see the visualization, you run the process based on your selection criteria. After the tool runs, actually, you will get some rankings between sites based on your selection criteria. So you have some scoring with color codes, and you can also export them. You can use them in the later phases. So we have rank 1, rank 7, rank 4 with some data parameters. The next step is the climate prediction. So in the climate prediction, you see, as you can see, there is one risk here, which is maximum air temperature is really high. And there is zero risk for that location. After you save your configuration, you can always reach it from site selection configuration. And for the grid impact study, here, these are all the substations for Morocco, for instance. And after you run the simulation based on different regimes, summer min, summer max, winter min, winter max, you are going to get a load flow. And now we are going to show you the violating substations based on your selection criteria. And then you can do some adjustments, electrical adjustments actually, 2-winding, 3-winding, shot compensation. And then you can see, are there still any violating substations or not? And also we can provide you some action summary, what you can do in the later phases.
Okay, just a tool. It does not mean that we will rely only on the tool, but of course, in terms of a process to help to take the decision, it's definitively something that is of great importance. And the tool is part of Assystem. We don't sell the tool just for information. It's not available on apps.
Okay, this is our last slide actually, and after this slide, we can have discussions more. But this is a wrap up of what we are interested in actually. While we started the project, project, we have 3 things in my mind: where to focus, what is our impact to the grid, and how can we rank and optimize. By design, SMRs have much lower footprints, but even though we have to comply with the regulations, we had to take into considerations of the exclusion zones. We want to incorporate actually climate change, and we would like to do optimized grid connectivity. And we would like to actually combine all these findings with years of experience with many engineers behind the scenes actually. So as Fred mentioned, this is not a tool, this is a solution. So our engineers actually is going to provide you, is work with you actually to provide how to overcome public perception, how to overcome zoning, how to overcome the real site investigation processes in the next stage actually. So altogether, we would like to start from very beginning, and then we will continue to the site surveys and then the site characterization studies, which hopefully is going to be a cost reduction, time saving process for you. And I think this is it for today.
So thank you very much. We hope that this presentation has been a topic of interest. Thank you, Gizem. Thank you, Onur.
Thank you.
As per the format of this speech, we can meet you with great pleasure in the small meeting room on the back side. Onur, Gizem, myself, and also some of our technical guys that are as part of the audience. And if you want, of course, we are pleased to invite you on our booth because we have a champagne cocktail, if we still have got some bottles. I'm not totally sure of this, but please welcome and visit us on Assystem booth. Thank you very much.
Thank you.